So, welcome back. Now, till now we have seen the state of a substance, the state of water substance can be traced on the phase diagram. So, here I would just give a summary of locating the state of the substance, water substance on the phase diagram, but there is still something missing, and let us find out from this slide what is that is missing till now. I have given the states at every possible places, but when I want to trace properties, when I want to get properties, there is something still missing, and let us see what is that part which is missing related to the state of the water substance as far as the steam table is concerned, as far as the phase diagram of water is considered. So, let us look at this slide, and in general now I will just summarize. The state of a substance can be found out from various places, and it can lie on various regions. So, depending on the Tsat or Psat values. So, I know that this substance where it should lie, I can compute and compare its temperature and pressure, and we had seen about that. We have seen the tutorial also related to that. Depending on the Tsat or Psat value, I can locate where exactly this substance lies, alright, in what form it lies. Is it a vapor, liquid, on the line LV, whatever. I can trace all those things from based on the Tsat and Psat value. I may use a steam table for this. So, there are 3, 4, 5 possibilities. The first possibility could be, it could be in subcooled or compressed liquid region, isn't it? If the temperature is less than Tsat value, if the pressure is more than Psat value, you could be in subcooled or compressed liquid region. Or if the temperature is more than Tsat value, or the pressure is less than Psat value, you could be in superheated vapor region, right? Or if the temperature and pressures are beyond the critical limits, alright, then we could be in supercritical fluid region, which is what we have seen earlier. Or if temperature is Tsat, pressure is Psat, we could be on a saturated liquid or saturated vapor region, alright. So, I know I am on the LV line here. So, I could be saturated liquid or saturated vapor region, and I can get all these properties for a given pressure P and T condition using steam tables. What is not known to me right now, there is one more possibility, is two phase mixture when I got liquid plus vapor region. The properties of this is going to be a question mark right now for you. So, if I want to get the properties of all these 1, 2, 3, 4 regions, I will go to the steam table. I may have to do some interpolation of properties, and I can use table 3, and I may use even for these properties I can use table 1 and 2 also. So, I can use these steam tables, and I can directly get the properties for these different regions directly from the steam tables. The problem is two phase region, wherever I got liquid and vapor existing together, and if I want to get properties for liquid and vapor together, I do not know where to go as of now, and therefore, this is right now a question mark for me, how to get properties of a mixture where the substance has got some vapor and some liquid together. They are together, they are existing at the same pressure and same temperature, alright. So, properties of two phase mixture, how to get from steam table is now a question. So, the answer to this is in a very important term called quality. The quality of a mixture is going to give the answer to get properties of a two phase mixture of liquid and vapor mixture, and let us now see more about this quality in the forthcoming lectures. So, introduction to quality is what we are going to talk about. Again, what region I am going to confine myself to now, alright. So, again I have got a PT diagram and a PV diagram. This is my L and V regions. I think most of you are now used to this, habituated with these slides, and if I take any condition which lies on a LV line, saturated liquid vapor line, I will be somewhere here. If I can draw a horizontal at the same pressure, I will be here, and now if I just look at saturated liquid line and saturated vapor line, alright. In this diagram I will look at only this point, while in this diagram, PV diagram, I can see on the left side of this dome and the right side of this dome. The left side is saturated liquid, the right side is saturated vapor, and if you recollect, the properties associated with liquid are UF, VF, HF, SF, alright, saturated liquid, everything is liquid over here. On this line is 100% vapor line. Properties associated with that are, for the dry saturated vapor is UG, VG, HG and SG, alright. So, got two regions, saturated liquid, saturated vapor, and the properties for these two I can directly get from the steam table, alright. This can be obtained from table 3 as well as from table 1 and table 2. My question is now two phase mixture which lies in between this, and if you remember that the difference between these two is delta U, delta V, HFG and SFG. The question is, if I want to get properties of the mixture which lie anywhere between the saturated liquid line and saturated vapor line or inside the dome, from this end to this end, anywhere you know that the mixture will be there, liquid and vapor in the varying proportion. I have just shown a representative figure here, vapor could be more, liquid could be less, whatever. Depending on where it is, how do I get the properties of a mixture which is in between saturated liquid line and saturated vapor line or under the dome, inside the dome. Here I will have to introduce one more parameter, quality. Unless I know the quality now, I will not be able to calculate properties of any mixture, liquid and vapor mixture which lies inside this dome, and therefore I should know quality, and this quality of the mixture actually would determine what are the properties of a two phase mixture inside the dome. So, I will just introduce this term quality to you, and then we will use this quality further to calculate the properties at various two phase mixtures that lie inside the dome. What we have learnt? Properties of subcooled or compressed liquid. We have understood what kind of approximation which we have to do for subcooled or compressed liquid. How do I get the properties of SUV for the compressed liquid, and we also understood the part related to enthalpy. In summary, I have shown the slide, we show the state of a substance could be obtained, and we lastly I just introduce you to term called quality, and this quality will determine actually the properties of the two phase mixtures. Thank you very much.